Let's continue our work with solving linear equations. And this time we're going to talk to you about the subtraction property of equality. In our last video, we talked about the addition property of equality, which allowed us to add the same number to both sides of an equation. So similarly, the subtraction property of equality, you're going to notice here that this time we're subtracting c from this, both sides of this equation. So this property allows us to subtract the same number from both sides of an equation and keeps everything equivalent, right? We're going to use that in our first example. We want to solve for x. X plus 6 equals negative 11. We want to know what number do we add a positive 6 to, do we add a 6 to, and get a negative 11 answer. So the subtraction property of equality can help us, especially if you're not as strong with positive and negative numbers. Sometimes it's a little confusing. We want to isolate x, but we have a plus 6 on the same side as the variable on this equation. So we're going to subtract 6 this time from both sides of the equation so that we can get x by itself. So rewrite my equation and then subtract 6 and subtract 6. So that comes from our subtraction property of equality. Okay, so here we now have x plus 0, which is x on the left-hand side. And here we have a negative 11 added to a negative 6, which is a negative 17. So checking, negative 17 plus 6 does equal negative 11. So x equals to negative 17 is the solution to this equation. In problem number 2, we have negative 16 equals y plus 4. We want to isolate y so that we can talk about what number do we add a 4 to get a negative 16. Now, if it bothers you that the y variable is on the right-hand side of the equation with this problem, we are allowed to rewrite. You can just rewrite the problem, putting the y plus 4 on one side and the negative 16 on the other. That's allowed. So in other words, if a is equal to b, then we can write b equals a. Now we are going to go ahead and use our subtraction property of equality here, and we have y plus 4, and we're going to subtract 4 from both sides. That will isolate the y on its own on the left, and here we have negative 16 minus 4, which is a negative 20. And checking, negative 20 added to a positive 4, that does equal negative 16. So our solution is y equals negative 20. Problem number 3, we have fractions, but we're going to use the same idea. We're going to use subtraction property of equality. I'm rewriting just because I prefer to have the y on the left, although this is an optional step. It's the 3/4 here that we want to subtract from both sides using our subtraction property of equality. On the left, we get a y. Now, to subtract these two fractions, we need a common denominator. And between 4 and 6, you probably know that that's a 12, right? So we need a number 6 can divide into and 4 can divide into, and 12 is the smallest. So we're going to go ahead and change both of these to 12 denominators, which means that for this 6, we multiplied by a 2. And anything we do to the 6, we need to do to the 5. So this is a 10/12. For the 4, we multiply by a 3. So this numerator becomes 9. So now we get 10/12 minus 9/12, which is 1/12. Y equals 1/12 is the solution to our equation. Okay, continuing our work with properties of equality and solving linear equations, the next property of equality that we're going to look at is called the multiplication property of equality. And if you think that that allows you to multiply both sides of an equation by the same number, you are absolutely correct. That's what happened here with the c. It got multiplied times both sides of the original equation. So that's really helpful, especially when we have these fractions, like in the first example, x divided by 6 or x over 6 equals 11. We want to isolate x. I'm going to put an 11 over 1 here, just make both of them be fractions. Okay, we want to isolate x. So what we're going to do is that we're going to multiply by 6 over 1. Because notice how on the left-hand side, then these two 6's will reduce, right? But again, Because of the multiplication property, that means we need to multiply this side by 6 over 1. Okay? And so then what happens? Well, on the left-hand side, we get 1x. That was the goal. Our goal was to get x by itself. And on the right-hand side, we get 66. And so we can check that pretty easily in our heads, right? It says 66 divided by 6, does that equal 11? Well, yes, it does. So 66 is our solution. In our next problem, we have 2/3 times x equals 10, and we want to solve for x. So what number do we multiply times 2/3 to get 10? And we're going to use the multiplication property of equality. So what we're going to do is we need to get this coefficient of x here. And a reminder that the coefficient of a variable is the number in front of it. So for us, that's our 2/3. That's the coefficient. We need that to be a 1. We need 2/3 x to become a 1x. And how do we get the fraction 2/3 to give us an answer of 1? Well, we can use the reciprocal. Multiplying a fraction by its reciprocal gives us a 1. So the reciprocal of 2/3 is 3/2. So we are going to use the multiplication property, and we're going to multiply both sides of this equation by 3/2. Notice me putting a 1 under that 10 to make a fraction, and then putting the 3/2 next to it. So again, what's going to happen on the left? Well, 3/2 times 2/3 is 1x, and that was our whole purpose, was to get that x by itself. And over here, we have on the right-hand side 10 over 1 times 3/2, and we can reduce the 10 and the 2 by 2, and that leaves us with a 5 here and a 1 there. Multiplying straight across, we get 15 over 1, or 15. Now, checking this, we can check by substituting our 15 over 1 and multiplying it times the 2/3. And 3 goes into 15 5 times. And so notice how we do get 10, which was what we started with in the equation. So x equals 15 is our solution. Again, what did we do? We multiplied both sides by the reciprocal of the fraction, the coefficient of x, which was 2/3. Let's use that idea again here with number 3. We have -1/2 x equals 15. We want to isolate the x. I'm going to write 15 over 1. So we're going to multiply by the reciprocal of a -1/12. And the reciprocal of a -1/12 is a -2 over 1. And by the multiplication property of equality, I'm going to do that to both sides of the equation. So on the left-hand side, we do get x, because -2 times -1/2 is a 1, positive 1. And then on the right-hand side, we get a -30. So checking. -1/2 of a -30. Changing those signs. Half of 30 is 15, isn't it? Yep, that checks. And finally, if you thought, well, maybe if there's an addition property of equality and a subtraction property of equality and a multiplication property of equality, there must be a division property of equality, and you are correct. So that allows us to divide both sides of the equation by the same number. So in this first problem, where we have 3 times x equals -27, and we want to isolate x, we're going to divide both sides by 3. Divide by 3, divide by 3. And that's going to give us x on the left and a -9 on the right. So -9 is our solution. In problem number 2, we have -9x equals -72. We're going to use the division property of equality to divide both sides by this -9, which will allow us to isolate x, get x by itself on the left. And here we get a positive 8. Negative 9 times positive 8 is negative 72, so that definitely checks. Number 3, we have negative 28 equals 4x. We're going to divide both sides by a 4. And that gives us x equals negative 7. And we know that 4 times negative 7 is negative 28, so that definitely checks.